I also, before I get into this, wanted to just let you know, is this the clicker? Sorry, that I'm honored to be in a room full of both brilliant people, but brilliant people who are really committed to changing the planet and the future of humanity for the betterment of everyone involved, and it's really an honor to be here. And I'm excited about how working with all of you to see how we can scale my technology globally as quickly as possible. So my name is Jeff Toolan. I'm the CEO and co-founder of PYLANTIS. We are a for-profit enterprise based in Japan and New York, and we make a variety of products out of a variety of waste matter for a variety of consumer applications, which you may currently know as plastic. So these are sort of the unplastic plastic. I started in endocrinology a long time ago at Cornell and some of the earlier endocrine mapping, so I've known for a very long time that there are some issues with petroleum-based plastic that were sort of unforeseen consequences of the mass adoption of this technology, and we'll talk a little bit more about those in just a minute. So our mission is to really replace all types of plastic. Now we can currently replace a wide variety of injection molded goods for your supply channel. In the future, we hope to be able to replace all types of petroleum-based plastics from your supply channel. Our products, as I mentioned, are made from a huge amount of organic waste, and that's really the difference between us and other types of bioplastic. We add this organic waste to a base of plant resin, which you may know as biodegradable stitches. Some of you may have had them at hospitals here in the US. And through the incorporation of waste, we're able to change the material properties of the end product. The product you're seeing on your desk is our newest material. It's still in R&D, and it's EcoPEC, and it contains 30% sawdust. We can do this up to 70% sawdust, which is really unheard of in the injection molding business because it's very difficult to injection mold solids. PYLANTIS would not have been possible due to the fact that my co-founder is from Japan. We work with people all over the world. If there wasn't a unified vision for remediation of this sort of toxic supply channel, this is important mostly because us as individuals have experienced a lot of environmental devastations lately. I'm from New York, and you all may know last November we had everything from a tornado to an earthquake to a typhoon that flooded the subways to a blizzard. This was all within a matter of months. And following that, I went to Fukushima, Japan to meet my co-founder, Michio Komatsu, who obviously had gone through a tsunami. So we've had a few obstacles in terms of getting to market, but it's really emphasized our commitment to the triple bottom line and our commitment to the environment, and also our commitment to safety at every level of our production. So we also look at the organization, and we structure the organization to model after the triple bottom line. So we incorporate this mission into even the organizational level. At the enterprise level, we don't forget about our producers either. The producers are just as valuable to us as employees, as team members, as any other part of the organization. And really, our products have a huge impact on society because they remediate an incredibly toxic, incredibly wasteful, mostly one-directional supply channel. The problem. We all know plastic's made from oil, and as the recent Gulf oil spill has proven, there's a lot of issues with the continued extraction of petroleum. And plastic consumption is expected to grow to over 500 million tons by 2020. And as you can imagine, that's putting a lot more plastic in our environment. And as the developing world adopts the patterns of the developed world, this model of consumption is no longer sustainable. Not that it's sustainable now. So there's other problems with plastic. It builds up in the environment because it's fundamentally not biodegradable. And if you can imagine, 80% of ocean beach water waste is related to the plastics industry. And ironically, less than 7% of this is actually ever recycled. And the number is much lower globally. And this has a lot to do with difficulty in sorting and just lack of incentives for the recycling of the product. Most importantly, and the reason Komatsu and I share an aligned vision, him as one of the most advanced injection molding industry leaders in the traditional plastics industry, and me as a sustainable entrepreneur with a background in human rights and environmentalism, has to do with the health effects. And there's a lot of evidence coming out of a lot of universities globally, and if you'd like to get some more information after the talk, I'd be happy to share it with you. But plastic is having an incredible impact on the endocrine systems of particularly women and children, also the environment. So it's really happening everywhere. We're seeing species change gender, or change sex rather, for no reason. I mean, we're really at a tipping point in terms of the amount of endocrine disruption that can be safely put into the environment because practically none of it is safe. So the solution, as always, with everything from all of the vaccines we've discovered, is here on Earth. And basically, our solution, because of the incorporation of, for example, the sawdust in here, is what's allowed us to become commercially viable at scale. So, and always has been. So basically, if you didn't already know this, all first-generation plastics were made from plant resins. They were readily available plant resins, which meant that they were moldable, or in a sense, a plastic. So celluloid, which was the first-generation plastics, was made from plants, and it was just because there wasn't an abundant supply of plant resin, and there was a huge amount of waste coming from the petrochemical refinery process. At that point, even unleaded fuel was considered a waste, if you can imagine. So the abundant supply of petroleum, the relative ease of use, really just led to the mass adoption of this product and this material, which was really very, seemed like a revolutionary material for a lot of purposes. It created safety, it created mass consumer scalability, but it wasn't really ever vetted for the long-term health impacts on both the environment and public health. So just so you get an idea, if you do know something about the plastic injection molding process, you can kind of forget most of it because the PYLANTIS process, we're not a material. We're an advanced mechanical process technology that operates in the same three phases that traditional plastic operates in the sense that we have a feedstock, which comes from waste or plant residue, products like recycled paper, recycled wood. For the most part, we think as long as we can get it into the form of like a flour, we can injection mold it. The technology or the equipment that does this is very different from traditional plastics to new plastics. And the output or the final product also has some qualitative difference. So for example, this is a cup made from our material, and it's about 10 times stronger than plastic due to our technology. So, this visualization, and it's funny because the NASA people were like, oh, you have Discovery, that's old technology, you got to put up Galactic. So I switched it out to Galactic, and it really, that's actually a fair representation. So we'll get into some more detail in just a second. So the traditional plastic production model, unsustainable toxic feedstock coming from oil, it's led to a very specific type of machinery used globally that can only handle this specific type of feedstock. But as you can see, there's a lot of material availability in the form of waste on Earth, and there's really nothing stopping us now from making a wide variety of product applications with our technology. So this antiquated technology, this antiquated feedstock, has led to a devastating disposable consumer culture, which we're all aware of. I'm not going to talk too much about this. The PYLANTIS Difference is our Pyllantic mechanical process technology. It's literally phase change technology, which allows us to incorporate solids into the injection molding process. And if that weren't hard enough, the actual process of getting these very delicate natural materials, which have been, in a sense, created molecule by molecule out of the molds, represented an almost 10-year-long R&D process involving the Japanese government, major academic institutions both here in Japan, and a variety of Fortune 100 companies that are partners of ours in Asia. So we've had to innovate every level of the plastic production process, from the feedstock to the compounding, which is when you mix in the waste, to the injection molding, the mixing again, the molding gating. I could go on forever. But the most important part is there's some externalities of this innovation which also are directly related to your bottom line as businesses and for the environment in terms of carbon, which is that our machines use 80% less electricity. This is a huge feat for just the machine alone if we weren't even incorporating another type of material into the process. And we can produce 99.98 production efficiency. That means there are very few seconds. That means this technology is ready to go at the pace, speed, efficiency on par or in front of the traditional plastics market. So yes, you can make these things as quickly, as safely, as perfect as the traditional plastics industry can. And we've really got an amazing portfolio of unplastics, and you'll get to see more of them later during the impact rotations. This would not have been possible without an incredible group of partners, and I mentioned it's universities, it's major Fortune 100 companies. One component of our system actually has to take more than 1,000 measurements a second, and that's so that we can completely articulate the heating and cooling process of these natural materials to maximize their material strength at the end point of the product's production, and also ensure that we can get it out of the mold so that it's the right temperature when we want to extract it. And there's EcoPEC, the first generation of literally recombinant wood technology. I just found out that I basically can't call this product plastic. There's a couple of reasons. One is that the Plastic Council has sort of use limitations, but also because if we were to make it with 70% wood, I would literally have to just call it wood. So it's injection moldable wood, and it can come in a variety of different densities, from an elastopolymer to a very durable grade material. So most recently, REPEC, which is this material, it's our first material to market, has cleared some of the most extensive vetting. My hat's off to the Nike material scientists and to NASA, because they were the first people that asked the right questions immediately. They really got to the punchline, and I was surprised because our technology is so advanced, but I was really intrigued that both scientists were sort of kind of were, in other words, it was one of the first times I was asked questions that were very relevant to the technology. A lot of times people have no idea. So hats off to Nike and NASA material scientists. Obviously 100% recyclable. Our idea is to move into more of an extended producer responsibility model. Our products, though they're compostable, we don't want them being composted. They're too valuable. They can be continually recycled in closed loop systems, which keeps the carbon in the products out of the atmosphere. Obviously, we've cleared our FDA leach testing. This product, Repec, was actually tested for the first time of any polymer with a no detection score in all 3 FDA leach tests, which means we didn't get a 0 or a 1, we got an ND. And literally the largest testing agency on the planet was a little bit like, wait, did we do the test wrong? How did this plastic product not leach at all? And this is being exposed to, like, you know, very hot water for hours and hours and hours. So indeed, this is the first generation of microwave-safe, dishwasher-safe, biodegradable plant plastic. So it's that's a material feat. If you've noticed the cups outside, they're a little bit melted. So this is just the beginning. Our business model is we have an existing R&D facility that's ready for commercial runs in the south of Japan. And we're really here to scale the technology in the US to bring our diverse portfolio of materials, which I mentioned can basically at some point replace all parts of a petroleum supply channel for consumer products, supporting a closed-loop future, driving additional revenue for permaculturists globally in terms of creating additional agro-waste of value, and with a focus on front-end waste reduction. Big money stepping in. Some of you guys in the room have already invested heavily in this industry, but everybody from Procter & Gamble to Pepsi to Coke to Walmart is in this game. North America, interestingly, will produce the most biomass in the world, right now does. But we're also the biggest problem. So the US represents both the solution and the problem simultaneously because we have access to the transitional materials and we're one of the biggest offenders. The time to change is now. This is totally unacceptable. I mean, I can't imagine what it must be like to live in this river and have to literally boat through literally almost a foot deep of plastic that's built up in the environment. This isn't the future anyone here wants to create, and it's the future PYLANTIS is trying to avoid. Why us, why now? Proven technology, dynamic engineers, top management. We have top professional services. Some of our IP attorney is the top one in Japan. He works for Honda as well. We have 48 active patents, 300 claims globally. We're going to bring this whole portfolio to market over the next 3 to 5 years. And biggest needs, financing. Obviously, we need to scale as rapidly as possible, and we can. Our back end is ready to scale immediately. And continued R&D to bring more materials to market that have different needs. Sustainable supply, we need to focus on managing the biomass and not exploiting the rainforest. We don't want to get off of one problem onto another. And we need to create a future where both bioplastic and food production are compatible. And new standards. We've had an incredible difficulty bringing our materials to market because they're so outside of the standards set by the industry that, for example, this wood case, even though it contains wood, the wood is testing false positive as oil because it's over 10 years old, and we have to do radioactive carbon dating to prove to the scientific community that we're actually using new carbon. So our wood is testing as oil even though we're using sawdust. So the standards are just all a mess, not to mention the focus on transparency from the industry standpoint and consumer messaging. So I'm really excited to meet all of you later in the impact rotation, and you can ask me a ton of questions about the technology. But thank you so much again, Launch, for this opportunity. It's a once-in-a-lifetime opportunity. I think take this technology as quickly as possible to the market.